All right, for anyone that's interested in the sphere problem with the cone inscribed inside of it, we know that the sphere has a radius of 3, and that was given. The sphere's radius equals 3, and what we can do is imagine um, a triangle drawn here where we call this angle theta, and this is also 3. Make this more clear, that's 3. So what does that mean? Um, that means that this height here, using trig, that's 3 sine theta, and this length here, using trig, is 3 cos theta. Mm-hmm. So the volume, and in terms of a cone, we have 1/3 pi, and I'll use big R just to differentiate from this R. So 1/3 pi r squared h, where r equals 3 cosine theta, and h equals 3 coming from here plus that distance, so plus 3 sine theta. So our volume equals 1/3 pi times 3 cosine theta squared times h, which is 3 plus 3 sine theta. Now we enter into a trig gymnastics course with some simplifying. So we get 3 equals 1/3 pi 9 cos squared theta, distributing that squared, times 3 plus 3 sine theta. Now let's factor out a 3 and factor out the 9. So when we do that, we have 1/3 pi times 9 times 3 times cos squared theta times 1 plus sine theta. Well, here the 3's are going to cancel off. And going down into our simplifying land, we get that our volume equals 9 pi. And what I'm going to do is I'm going to change cosine into sine so that we have everything in terms of sine. So this is 1 minus sine squared theta using the trig identity. Sine squared plus cosine squared equals 1. So 1 plus sine theta. And continuing on, we get 1 plus sine theta minus sine squared theta minus sine cubed theta. And oops, I think I made a mistake. Let's go back up to here. So that should have been what we should have done is said V equals 9 pi and then distribute cos squared theta plus cos squared sine theta. Yeah. This is what we wanted to do. And now we can, so we stop there. Now we take the derivative of this. So the derivative of this equals 9 pi times negative 2 cos theta sine theta minus 2 cos theta sine squared theta plus cos cubed theta. So doing a bunch of chain rules and product rules. And we see a bunch of cosine thetas, cos, cos, cos. So we can take that out. And when we take that out, we get v prime equals 9 pi cos of theta times -2 sine theta minus 2 sine squared theta plus cos squared theta. And this is where we're going to replace cos squared theta with a sine squared theta. And I'm going to do this on the next page. So we have, let's see, derivative equals, where am I? 9 pi cos theta minus 2 sine theta minus 2 sine squared theta plus cos squared theta. And then we can rewrite cos squared theta so we're going to rewrite that as 1 minus sine squared theta. So we get 9 pi cos theta minus 3 sine squared theta minus 2 sine squared theta plus 1. And then, oops, this is just minus 2 sine theta. Factor out a negative, negative 9 pi cos of theta times 3 sine squared theta plus 2 sine of theta minus 1. And then we get negative 9 pi cos of theta, 3 sine theta minus 1 times sine theta plus 1. And what we need to do is go back to our original triangle that we were drawing, where this angle here is theta and this is 3. So, and here's my derivative. So if my derivative to be 0, either cos of theta equals 0, and if that's true, then theta equals 90 degrees or 180 degrees. And if that were true, 90 degrees or 180 degrees, this sphere or this cone would have no volume. It would just be height. And also, we could have sine theta equals -1, in which case theta equals negative pi over 2, or yeah, negative 90 degrees. And here, this would also result in an angle where I had no radius on my cone, so this won't work. So the only one that works is 3 sine theta must equal 1, or sine theta must equal 1 over 3. And given that my radius of the sphere is 3, that this value is 3, that means this is 1, and this side here is root 8, and this is 3. So the volume of that sphere, and here's where our long trig session ends. The volume of the sphere is 1/3 pi r squared h, where r is root 8 and h is 3 plus 1. So it equals 1/3 pi 8 times 4, which equals 32 pi over 3. What a beautiful answer. And that's the max volume. Take a stab at understanding that. It's a little bit challenging, but fun to think about.